Hello and welcome to another Sneak Live. My name is Brian Clark. I'm a developer advocate here at Sneak, and I'm one of your hosts. And your other host for today's session is Kyle Swerow. Hey, Kyle.
Hello, how's it going, Brian?
It's going well. I'm really hyped up and excited for today's session because it's more Log4j juiciness, right?
Yep,
Yes.
we had a little break from it, but now we're back with some Log4j awesomeness. And I say awesomeness because these folks actually made it onto our Log4j awesome or our Log4Shell awesome list with this really great open source project that they were working on in their free time. So I think without further ado, Brian, let's invite up our guests.
There we go.
All
Hi,
right,
Brian.
hello.
Hi, Kyle. Nice to meet you.
Hey, how's it going?
Hi Kyle. Hi Brian. Great.
So maybe we can start with Johannes, and then we'll move to Andreas, and we can talk about a little bit about what you do at Code Shield, and then we'll get into the project.
Perfect. Yes, so I'll start with a short introduction. Hi, I'm Johannes Speth. I've been doing research for over 5 years and in computer science. Have a background actually in mathematics, and then did some research in static code analysis. Did some new algorithms there. Invented some new algorithms that could detect like crypto misuses and all that stuff. And I've been working in industry for over 5 years. With Fraunhofer, which is one of the largest German research organizations, and I've been doing like several industry projects there. During that time, I also went to go to Oracle Labs during my PhD, which I also enjoyed working at in Australia. So that's to me so far.
Okay, yeah, I'm Andreas. I'm also one of the co-founders of Code Shield. I met Johannes when he was working at the university because I was in the same research group, and I was also working on static code analysis and also on software composition analysis. So how can we efficiently detect vulnerabilities in open source components? And I was working on that field and also working as an intern with SAP on a public detection engine, Eclipse Steady. Yes.
Awesome. So I think that's a pretty good intro here. So maybe we can get into Log4j, or sorry, the Log4j vulnerability, Log4Shell. So maybe we can talk about like what the actual problem is. Brian and I have sort of discussed this, like written stuff on it and everything, and y'all folks have of course made this repo. So from your perspective, what's the actual issue with Log4Shell, and how long do you think we'll hear about it?
Yeah, that's a really good question. And so I mean, to be honest, so Log4j is just something that just appeared like early December, but it will last for I think a couple of years still, just because the impact is so big. And that's also why at Code Shield we actually decided to do that as a side project, our bytecode detector that we will be speaking about more in the future in this podcast. But the problem really is that it's so such a big issue because first of all, clearly it's a logging library, which is basically every software project in Java uses any logging library, and they just hang around there. But then there is like a lot of libraries that you use, like logging libraries, are just the thing is really it's one of I think there's another logging library, but this one is the most used logging library in Java in general. But then the problem really is that we have these jar files. The problem is that for many projects we have different packing and packaging mechanisms, such as jar file bundling, fat jars, and so on. And all these packaging mechanisms make them super difficult to detect this vulnerability. Like we have Docker containers, we have a VM in which we just deploy jar files. We have all different types of bundles that are out there. We have Android applications, for instance, as well, which are basically jar files and that may still contain the vulnerabilities, and we don't know in which version it is anymore because we may not have the source code relation, all that stuff. And I think these like systems will be there around for the next couple of years still.
Actually, and in addition to that, I guess one of the major problems is that, and that caused some panic, is to find out which software actually includes Log4j. I have the feeling it's more or less like an Easter egg hunt. So you have to look into all corners and look into all dependencies and all software libraries that you may include. And also Google recently published a super interesting study about it. They checked only to a certain level how many dependencies or libraries on the Maven Central repository included directly. And they came up with numbers 17,000, 80,000. But this is only the surface, because most of the time when you look into vulnerabilities or in different studies, it's not the direct dependency that you have in your project itself is not affected, but somewhere on the level, on the depth level 4, 5, 6, 7, a transitive dependency is affected. And you have to find out which are my transitive ones and do I have Log4j included. So I guess the community knows it as dependency hell, and that's why I think it will go some time until everyone finds it.
True. I think it's really like the iceberg, the tip of the iceberg that we have been seeing so far, but all what's below will be coming and still needs to be updated and fixed. And yeah.
You both are. I'm laughing because of your funniness about like discussing it, but also the common parallels to these presentations that Kyle and I do with customers and just developers in general. We talk about an iceberg, and our code is just like the focus that we think from a developer perspective of like, oh, I just got to worry about the security there. But really, our dependencies make up, and there's been studies that we share that Sneak has done where like 80 to 90% of your code base is actually consistent of dependencies. And then in addition to what Andreas was saying, a lot of times when these vulnerabilities come up, it's not from your direct dependencies, it's from your transitive dependencies that we describe them as. And then we go into, oh, this is how Sneak can help you at least get alerted to that and help you fix those things in a timely manner and that kind of stuff. So you're hitting it all like spot on. You're setting us up perfectly here at Sneak to promote it, So, but yeah, so it's very, very interesting, the whole Log4Shell situation. And I guess my question from a developer's perspective for both of you is, when we talk about bytecode, right? Like that to me, I'm going to admit I'm a dummy. Okay. And like, it's been a while since I was in college and I studied this stuff. What is exactly like bytecode detection that you all have kind of done with this to kind of just set the stage before we go into the weeds of like how this all came to be? You all started working on this. Let's level set for some people that might be like me, where we're like, what is bytecode detection? What does that even mean? Is that like a common thing in the security space that experts do to help kind of weed out these things and find this stuff?
Sure, I can take over that. So the bytecode is really what actually will be executed by the Java virtual machine.
Okay.
So you start from the source code, which you have in the Git repositories, and then what you typically do is like a compile step where you run Maven or Cradle, for instance, and this will basically like compile the source code into what's called bytecode, machine readable format that will be interpreted by the JVM. And this will be then executed actually. And there's like a lot of performance improvements that will happen during compilation, refactoring stuff, all that will be applied during compilation. And then only the bytecode will be executed. And that's the bytecode. And what typically another thing is that if you that's a bytecode, and then you have the bytecode in which you need to detect these vulnerabilities. Also, like normally when you include dependencies, there are mechanisms like Maven dependencies which you include in your project, and they will be typically included as bytecode already. Meaning they will be loaded as precompiled jar files from Maven Central, for instance, a big repository where you download all these dependencies, and they might be bundled into your actual execution file.
Excellent. That's super helpful. Andreas, anything to add to that from your perspective?
So to put it on point, basically to detect such vulnerabilities like the Log4Shell vulnerabilities, you have basically on a broad scale 2 options. You can do it directly in source code. So when you're programming, you have the source code of your program. And for instance, when we talk about Java, you usually have POM or a Gradle file that declares all dependencies that you include. And during the build process, you build your Maven or Gradle, pull up all dependency, and you see, okay, what are the transitive ones and which are actually included in my project. And then you can run any vulnerability scanner to say, okay, this dependency is actually affected. So this is the source code approach. And the bytecode approach is you assume you don't have this POM file or this Gradle file, and you don't have the source code anymore, but you only have the executable jar file, so the compiled output. And we, or our scanner, looks into the compiled bytecode or in the compiled jar code and searches there for jar files, or to be more precise, classes that are vulnerable to the Log4Shell vulnerability. And why is it interesting? That's always a question, because at least I, and I guess most developers, love serverless functions and containers. And when you build code for serverless functions, you usually put all dependencies and all bytecodes that you have during the compilation file into a single, someone call it uber jar or fat jar file, and then upload it into your, for instance, Lambda function or in your Docker container. So when you want to check these, you don't have the source code anymore, or in most of the cases, you don't have the source code anymore or the POM description. Sometimes it's packaged into the fat jar file, but you have to assume it's not there. So you have to check the bytecode, which is actually executed in your container or in your serverless function.
Gotcha. Yeah, that was both of you. Thank you so much. That was super helpful for me. That's kind of new to hearing that term and understanding what's going on here. And it kind of clicked for me also in the situation where, and maybe this might apply and you both let me know. Like I have a Raspberry Pi at home here, and I know that there's a Java service that I use on there that I was running for various things like IoT type of stuff, right? And this is where things start getting really interesting with these vulnerabilities too, as IoT starts becoming more prevalent across the globe. For now, I just took it off my network, but like, and I just shut my Raspberry Pi down because I'm like, I don't want to take the chance, and I haven't had the time to really dive into this just yet. But there's a service on there that I don't really have the source code to, or I don't have the access to it. So this would be super helpful for me to know if Log4j is being used in that service that's running on my Raspberry Pi kind of thing. So thank you for helping explain that and giving me the thought of like, I have a solution to go run with to figure this out.
Exactly, and that's another use case of the bytecode detector as well. There's like on the README, we also have a way of executing the bytecode detector in a way that it checks your running Java processes, and that could be a use case for you on a Raspberry Pi, basically, where it checks every running Java application on your system.
Yeah, and Brian, the case you just described is exactly what we experienced when we wrote our detector. We first, before making the repository public, we gave it first to some friends to check it, and they said, okay, you have this detector, nice, but I want to check my running applications without stopping them. So yeah, this is what we added, because obviously a lot of people had that scenario like you.
Nice. Well, now we're friends, so you can hit me up next time, right? For the next big vulnerability, and I can make sure I'm safe too.
Definitely.
Cool. So you described that you all started creating this bytecode detector. Tell us about how that came to be. Like, tell us the story behind it, the timeline that this all happened. I would love to hear the history of it.
Actually, we wouldn't created it because I didn't detected what we had. I guess it was Friday night or something like that. I was going out of office, wanted to grab my Friday evening beer, and then I saw on the security bulletin board or on Reddit, I can't remember. I saw Log4j and I just pushed it on our shared to-do stack. And then I went home and grabbed my beer. And then the next day, Johannes directly gave me a call.
Yeah, so I was in contact with several friends of mine who also, some of them are running companies that are also like, well, okay, what do we need to do? We need to quickly act on. We have a couple of applications running. What do we need to do? Do we need to act? This is a serious problem now. And clearly, like over the night was just crazy on how it also like built up, and we read more about it as well. And it was just such a big problem, and became clear on Saturday that we had to act. And yeah, at this point we said, okay, let's start working on that. We have basically, we have some ideas on how we can solve the problem. Let's go ahead and do it. There's also part, like the actual project is part of the whole story as well. There's also a whole mechanism behind. So we went actually did a whole study on Maven Central, which artifacts in Maven Central are also affected on. And that's also like we saw that first of all, we had been doing a lot of research ahead of that in this area, and which we could apply to kind of warn users which applications are affected, as well as writing a minimal detector that we published there.
Yeah. So basically, I had plans for the weekend, and Johannes then told me cut your plans. But unfortunately, it was anyway. The sports club was closed due to Corona, so there were no big plans. I had to skip. But he told me, okay.
So you were relaxing, drinking a beer, and meanwhile Johannes and folks are like feverishly, how do we get this, to sort this out?
Yeah.
Andreas, what are you doing? And you're
exactly
kicking back.
Exactly.
Nice.
But we got him in on to work over the weekend as well, and he joined, and that's why we could make it to publish it on Sunday night.
Well, we joke about it now, but all as a developer, at least, I want to, and maybe speaking on the developer community's behalf, we thank the work that you and other security experts had done over that period of time to help really accelerate us to be able to fix the issues and plug up any vulnerabilities related to Log4Shell. So, honestly, thanks for that and taking the time to do that. I know we joke around, but it is serious work, and it's good to have you all, folks like yourselves, looking into that stuff.
Actually, that is something that we learned, maybe also because of our research background, where we also contributed to a lot of open source projects, that open source is really, really helpful to a lot of people. And due to platforms like GitHub, Twitter, it's really easy to put out something. And even if it's not helpful for anyone, in the worst case, you at least have a lot of fun and experience. And in the worst case, you learn a lot about collaborating and coding something. Because that was our main intention, basically.
For sure. I think, in lots of the folks that we've had the pleasure of meeting and talking with about this particular topic, that seems to be a common thread, is like the community aspect of it coming together and rallying behind finding a solution as quickly as possible. And especially when the new, like, kind of, if you will, variants came out with Log4Shell there, and the different subsequent vulnerabilities that came to be discovered, right? So yeah, that's awesome to see. And it's very encouraging to me as somebody that's fairly new to the more of the security space and community, and coming from the developer community. It's very encouraging to see and hear that. So that's good. I'm glad to see that even reinforced with you both too. Kyle.
Yeah, so I actually wanted to know. I know we have a demo plan, so I won't get into the nitty gritties yet. But I was interested in finding out, like, y'all obviously open sourced this, and it was a community effort. Did you get any interesting contributions from the community, or any good contributions?
Yeah, so definitely we spread that across several channels. We definitely reach out to many people also. They put it on their advisory boards within companies. So it spread quite widely. also were mentioned by several online newspaper magazines and stuff in Germany and worldwide. And so regarding contributions, so yeah, we definitely had several issues that were opened, that we also took care of and resolved if there was an issue or did further explanation. We had some pull requests that we merged, and also it's really happy for us. We are really happy to see people contributing to their project, because that's really important. And so we saw that there was quite some usage of this project. I'll go into detail in one interesting contribution later on, but I'll do that during the demo actually.
Awesome. So yeah, we have some more questions. I mean, one of the questions that I have particularly is, did you already know how to make bytecode detectors before? Was this just some knowledge that you already had, some prerequisite knowledge that you just reapplied, or was this your first time making a bytecode detector? Was it completely from scratch? Did you use something else as a base for this? So I'm really interested in how that sort of kicked off.
Actually, yes, I worked in the same research group as Johannes, and my topic was detecting vulnerabilities on bytecode. So I also had some homegrown projects regarding that topic, but I never had the chance to make them publicly available. And during my internship and with SAP, I also worked on this topic. So I had some experience before, and I also recognized that besides Log4j, that there's an issue that I've not yet seen talked about a lot, which is, for instance, that not only Log4j itself is affected, and not only direct dependencies, but that what we have on Maven Central, a lot of jar files have the Log4j code rebundled or, for instance, shaded into their own jar file. So this is what we actually quickly recognized. We have a few hundred of jar files on Maven Central that also include the vulnerable code and that are not checked by typical vulnerability scanners that only check for the typical identifier group ID, artifact ID, and version. And that's why we created the bytecode identifier to also cover these cases, because in the worst case, people are affected without knowing and have a false sense of security.
Definitely,
Yeah, so
that makes sense.
definitely we have a lot of knowledge in this area in bytecode, general bytecode analysis. So that's where our research has been applied mostly. Like Andreas has been working on basically software composition analysis. My PhD was on topic on static application security testing, basically, where I wrote like a tool called CogniCrypt that basically allows to detect cryptographic misuses of APIs. So basically usage pattern within that you need to follow, especially like crypto misuse is quite widespread, where you basically have to detect that you use correct parameters to your cryptographic functions. And that's a super complex topic by itself, but we wrote like a tool that would analyze basically jar files and detect crypto misuses. And so that's really like knowledge that we have been building up over the last years, I would say, and that we then incorporated into that project.
And we have a very interesting question by Eric. I just saw that it popped up. First, thanks for the question and your engagement. The question is if or how, if I understand it correctly, shaded jar files impact the bytecode detection challenge. So this is a very good question. I can answer that because I just wrote a paper that was the result from my internship at SAP, where we compared 5 different vulnerability scanners, how they perform on shaded or rebundled jars, and we found out none of the scanners was able to identify vulnerabilities in shaded or recompiled jars. So this is a challenge, mainly because when you shade a jar, you have basically two options: taking the original bytecode and rebundle it into the jar file, or the other option is that typically is used when with shading is that you prepend a prefix to the package name. And this also changes the char file, because in the bytecode, the package name and also references to the import statements are modified. So this is a real challenge for the plain bytecode detection. What we did on our project is to identify these rebundled I just talked about. We use static analysis, and we worked on an approach that identifies shaded class files even if they have been recompiled or if the package named has been changed by having a further level of abstraction from the bytecode. I hope this answers your question.
Awesome. Thank you so much. So, yeah, I think we've been over how this differs from other bytecode solutions, and we talked a little bit about rebundling. So, can we talk a little more about rebundling and the impact that that has maybe on normal bytecode detectors as opposed to the one that y'all have produced?
Sure. So I mean, I think the impact is quite big in general for the Maven ecosystem. So I think generally like these shading and so jar files are basically packed in jar files, and we have these fat jars and uber jars which basically contain all my dependencies, and that's really a big challenge. But then, as Andreas also just mentioned, these shaded jars are the problems then as well as these repackage and rebundling, and that's where we really where we actually where we have also been working on solutions the problem. And that's actually so our open source project basically consists of two components. One component is basically the detection mechanism, but the other component is a list of artifacts on Maven Central that are actually affected by the Log4j vulnerability, which we pre-computed. And for the pre-computation, we used all these information on Maven Central that we have been pre-computing. That was really like an attempt to make our Log4j detector, bytecode detector, way easier by pre-computed some information.
And to go back to the beginning, I think the real issue of shaded jars is not Maven Central itself or JFrog or whatever public repository, but the real issue is the enterprise nexus that you have in your company, where you publish just your artifacts and you don't know anymore what maybe is contained in it. And that's why I called it initially an Easter egg hunt.
I think that's a very, very fitting way to describe it. I think for some folks and some orgs, it definitely is an Easter egg hunt. So I think, yeah, you know, also at Sneak, we have worked really hard to make it easy for people to detect that stuff, and you know, even came out with a new tool in our CLI to do it. So I really love seeing how, if I understand correctly, you know, this arose in your organization out of the necessity for a tool like this, and then y'all open sourced it. So I love seeing things like that. You know, I think we take a very similar approach here as well. So it's, you know, a very refreshing thing to see in this industry. You know, we've been in security for a while, and I think, you know, seeing stuff like this definitely, you doing stuff like this, you know, makes the industry better. It makes the security community better. And I think it also, you know, as we're doing right now, it helps educate like swaths of folks. So thank you guys so much for this. Should we get into a demo?
I would love that.
Yeah, sure. Just give me a second, please, and I'll share my screen. It's really just a short demo that I'll be giving. Give me 2 seconds, please.
Sure, no problem. And while you're doing that, I want to try this again. I think I can become Patch. I've just noticed this before. I get distracted easily.
Oh, you're gonna. That's perfect. Somebody needs to like screenshot that.
That's why I put myself up here, Kyle.
That is perfect.
I noticed your head was kind of getting hidden behind the logo, and I was like, wait, we can make our head go right behind Patch there.
I love this.
So while Johannes is getting the demo set up, I want to remind the viewers at home, if you have any questions, and thanks to Eric who asked the question earlier, and by the way, Andreas and Johannes, Eric said thanks, so you answered the question. It was helpful for him. Thank everybody that's watching at home. If you have any questions or you're watching this later, drop the questions in the chat or in the comments below, and we'll do our best to answer them and see if Andreas and Johannes can help us out with that. All right? Are we all set, Johannes?
Yeah, so I'm ready to set. Just
I see some more comments in the chat. Sneak is saying hi, Brian. Or maybe that's Patch actually talking to me in chat. That's interesting.
Oh, I was saying hi to other Brian.
Oh.
Brian G.
Oh, duh. The other Brian. OG Brian, as we put it.
Yep.
All
Eric
right,
has
I'll
a
do it again,
question.
LaRon. You can get a screenshot.
Oh, there we go. Let's do that.
all right. So I'm set up now. Ready to start.
Okay, yeah. Enough of my shenanigans. Here we go.
Okay, cool. So yeah, let's get started into the demo. So here you see we also posted the link initially in the chat, the link to our bytecode detector on GitHub actually. So you see this project, there's a README which you can read through, and there's some additional information, some of which we've covered already in the beginning. And the really basic thing is what you need to do is you go to our releases, download the latest release, and then you basically follow the README, and it's really just one command, which allows you to basically run our bytecode detector. So I've already set it up in my terminal here.
Really quick, could you zoom in or and scale up the terminal for folks?
Of course, sorry.
No problem, no worries. It's a common thing, don't worry.
Yeah. Is that big enough now?
Maybe a couple more times. Perfect. Yeah, that's good. Thank you. I'm already having bad eyes.
Yeah, no.
You know.
Thanks for noticing. Thanks for sharing.
In my young age, my eyes are going. I'm sorry.
So I'm here in the folder where I have several jar files already put in. So I have the actual JavaScript depend or Log4j detector, and then I have 3 jar files that I'm going to be using during this demo. So really, it's super easy. Like it's really just running a jar Java command, Java -jar, and then Log4j detector. And then this will automatically run our detector. And the first argument you just pass is basically a jar file that we want to analyze. Let's start with some XML validator that we're going to be analyzing. And if you then execute the command, it really just outputs information for you. So it did analyze the jar. So what it will be doing is really go into the jar file, unzip the jar file. It's basically a jar file is a zip file. So it will unzip it and then iterate over all files and detects and scan all files. It will scan, first of all, pom.xml files and checks if there are any declared dependencies that hint to our Log4j version. And then also it will scan all class files and checks if the class file matches any vulnerable class file. And so for this XML validator, we actually directly found the vulnerability. So we found, first of all, it's been declared as dependency in this pom.xml file here. But then also it found the vulnerable class files in these class files. So it outputs basically the relative path within the jar file to the vulnerable class files. That's really it. So if you don't have a jar file, if you have a jar file that isn't vulnerable, for instance, our own Log4j detector, because we made sure we don't include it for sure. the vulnerability. Sorry. So if you run
Nice.
the Log4j detector without with a jar that isn't detected, obviously it will report that's not affected.
Awesome.
So it's really easy. Go check out the README. It's super simple and super basic, but it works and detects the vulnerability. Yeah. So
Oh, go ahead.
other questions, Brian? Sorry.
It says, well, if the stream froze for Laron, I think it's just Laron.
Yeah, just Laron. I have it open in another window,
Okay.
like as a viewer.
Yeah.
Oh, but I did want to ask, actually. Oh, go ahead, Brian.
No, go ahead.
So I did want to ask about issue number 8. I know we're going to talk about that. So, you said, this is a particularly interesting PR. Maybe we can talk about it and the Log4j versions, and then we can talk maybe a little bit about how that progressed and how y'all responded.
Yeah, absolutely. So there was one particular issue that actually someone raised. It's Ben Douche, so contributor that raised an issue in our GitHub repository, and the question was, there was like these many variants, as Brian told them, of these Log4j, which were dangling around, and we had to update and update all the time because they were like yet another vulnerability in the new versions, as we all know. And yeah, clearly also we had to update some changes, and someone basically our detector flagged 2.16 as not being vulnerable, but then for version 2.17, suddenly one class within 2.17 was flagged as vulnerable again, and that rang a bell. So we were like, okay, what's going on now? Why is our detector flagging this one class as being vulnerable again? And we really we made sure the project was working as it was supposed to be, and we looked into detail, and finally, so the challenge was basically that our initial detector is basically based on the assumption. So we take fixed commits, and from these fixed commit that fix the vulnerability, we basically derive the vulnerable bytecode variants that are around. But we found out that this assumption, so we initially on Friday evening when the vulnerability was out, we basically had a look at which fixed commits were available, and we found initially, thanks for sharing my screen again. So we found initially these 3 commits, and after these 3 commits, so there had been more commits between version 2.16 and version 2.17, which basically reverted some of the changes again. And due to the revert of these changes, our detector basically flagged the vulnerable version again. And I can show you in detail what actually happens.
So we were pretty confused. We had this bytecode detector and we had the fixed commit. So we saw this classes has been fixed. We computed their bytecode. And then suddenly someone made the issue, hey, a version that has been reported as fixed is detected. And and then we found out for some reason, the bytecode that has been fixed has been reverted, and did cause at first a bit of confusion on our side. But yeah.
Give me a second, and I show you where this issue was, and which version and why it was so confusing. So we went through basically the whole history of this repository to understand which changes had been made. And as you see here, this is the so if you go to these changes here in fixed commit number, this one, you see that JMS appender had been, so it was related to this class JMS appender. And if we see here, there have been changes. Let's search for that. So in this fixed commit, they basically, this is the initial fix commit that was on Friday evening. So where they basically added some sanitizations to some whitelist about the hosts that should be allowed for LDAP lookups. And you see there were some changes that have been added here. That was from version 2.15. So assuming the green lines would entail the fixed commit, so the green lines need to be there that the version is not vulnerable. And that's something that we checked in version 2.17 then. Let me go to that class as well. So by the way, on the right, I'm showing you right now a basic decompiler, which shows like what actual content the jar file has. So I've opened here my Log4j core in version 2.17.
Nice. Okay.
And let's go to the JMS appender build method. Here it is. So here you see the jar file and the contents of the jar file basically so here you see line 103, and this is version 2.17.
Yeah.
And this was the change for version 2.15, where they introduced the additional properties to basically sanitize the whitelist approach. So for some reason, in between version 2.15 and 2.17, they changed these lines again. They reworded these changes, and they were basically, and we wondered, are they introducing the changes again? Did they introduce the vulnerability again? And that's what we then found, that there was a commit basically that reverted many of these changes between version 2.15 and 2.16 and 2.17. And that's what we then found out, that they had to revert many of the changes that they introduced, and that basically showcased this variance that were around that we then detected. So eventually we removed this class because we looked into the fix, and the fix seemed fine. So we finally removed this class as being responsible for the vulnerability, and so therefore the bytecode detector is working fine again without flagging 2.17, because we initially basically labeled too many class flags here.
Wow.
That makes sense.
So because it was really flagging only this one initial inner class, so it's an inner class, the builder JMS appender builder class of this. So it was really just flagging one class here instead of the whole class.
It's pretty awesome. So I think we have a pretty relevant question for what we're talking about now. But Alice is wondering, funny enough, because their name is Alice Wonder, but Alice is wondering if you can expand on the fingerprinting. So like how I know we talked about it a little bit, but maybe we can, if you guys want to go a little more in depth in it, we can talk about how you're fingerprinting the bytecode.
Yeah, I would really love to answer that. And by that, I would also answer Eric's second question, which is also directly to the point. To repeat it, he asked if we have different matching patterns for different versions, exactly, for different versions of Java-C, which is a Java compiler, or is it the bytecode uniform across versions? So this directly hits the nail on the head. When you have different Java compilers, for instance, the Eclipse compiler, or if you have different versions of the Java compiler, for instance, one for a compiler for 1.8, a compiler for Java, what is the most, 11 is popular, and 16 or 17 is the newest release. They produce slightly different bytecode. And the bytecode is, or the JVM is a stack machine, so the bytecode is stack-based or register-based. What we do, we don't use that bytecode as a platform. but we create semantic equivalent 3 address code based on the bytecode. And then we use static analysis to find loops or that code and remove that from our 3 address code representation. And we also modify these 3 address code implementation to, for instance, do string handling uniquely. And based on that, we then have a unified 3 address code representation of the bytecode that can be produced from bytecode that has been compiled with Java C 1.8, from a compiler version 11, 13. So we create one unified representation.
That makes a lot of sense. So you're kind of like extrapolating what it would look like in any circumstance, regardless of the version that it's compiled with. Awesome.
Exactly.
Do we have any other questions from the chat? We'd love to get to them.
We don't at the moment, but I'll buy some time for folks to ask the questions in the chat to send over lots of thank yous, Johannes, for that demo from folks. We have Al CICD, Dan B Dev, Birmingham 13, all saying thank you for that demo. So it was super helpful for them to kind of see that. And lots of people just saying very cool, good vibes. Brian V was also mentioning that the 17 is the newest Java compiler, if you will. Am I using that right? I'm not a Java developer, but yeah. Yes?
Java compiler. You got
Okay,
it.
cool. Yeah.
And Brian Vermeer is our resident Java champion, so
yes,
very, very glad to have him in the chat today. I'm sure he is loving this right now. So hi, Brian. But yeah, thank you guys so much for coming on. I think we've gone through every question. If anyone has any questions for our guest today on YouTube or Twitch, we will see it. So feel free to just drop it in the chat. Awesome. Brian, do you have anything else that you'd like to ask our guests, our esteemed guests?
No, I think that's it. I guess let's give them an opportunity to say any final closing thoughts that they'd like to share. If there's anything that maybe we missed that you were hoping to get to, now we have still a little bit more time. If you want to cover that, let us know. If not, we can start closing things out.
Yeah, perfect. Thanks a lot for the awesome time. So it was really fun being here and speaking about our detector. Like as usual, like we at CodeShield are really happy also to speak about the work we have been doing, and yeah, just saying that we also at CodeShield we're working also on technologies basically where we apply these technology also in our product to basically detect vulnerabilities in cloud native applications, but really from not from source code level, but we focus really on deployed applications within, for instance, the AWS accounts. So if that's something where you're interested in chatting more about, Andreas and I are always happy to get connected and speak about that.
Yeah, and I would also love to answer LCCD's question. If you could make
Sure.
it a bit more concrete, what do you mean by non-publicly accessible components? So when you mean, for instance, in enterprise Nexus repositories, there we have the issue that we really need to check the bytecode, because most vulnerability scanners use the meta information group, artifact, version, and classifier, and say, okay, this jar has this group, artifact, version, so this is vulnerable, but this doesn't work in non-public accessible components if, for instance, the group ID has been changed, or the artifact ID, or the version number. For instance, this can happen, or I've seen it a lot. People fork something, then apply their own fix, and then publish it with slightly modified version number, or by appending, for instance, _fix to it, and then pushing it into their own repository.
Excellent. Thank you for it's nice when the guests are on top of the chat like that and you're able to notice those and pull those questions in. So well done there, Andreas.
Awesome. The
Um,
only other thing that I'd add there, just to expand on that, is that's also something that we do work a lot on. If we're talking about SAST or SCA, right? So if you want to find vulnerable dependencies in your own, your own private source code, your own private repositories, your own private packages, no matter wherever you're storing them, you can always use Sneak and integrate it into, every step of the SDLC, the various tools that we have, whether that is SAST or SCA, in order to find out any vulnerabilities, either from dependencies or from your own source code, and even both. So yeah, I'd say ALCICD. That's and I like how your name has CICD in it, because
Mhm.
I like DevSecOps. But yeah, if you're looking to up your DevSecOps game, which it sounds like it, I'd say just take a look at all the integrations you can do with Sneak and other tools and platforms like our partners here.
And then one other comment from Laurent was about potential other reasons for bytecode detection only is when it might be some legacy code, right? Maybe, has that been another use case that you all have seen, and the source code is lost for that kind of thing? Have you found people having that use case?
Yeah, absolutely. So some companies also contacted us regarding that point, and really they were wondering about, like, it's most of the software that we're running is not our own software, but yeah, either legacy code, which is like outdated software, or third-party code. And
Yeah.
so for both use cases, they actually used it and found that.
And another more simple reason is checking the programs that are actually executed right now, because the class path that you use during the build command must not be the class path that is actually used during when you start up or when you fire up, for instance, your server. There can be slight variations, or different jars can be included, and for that you need a bytecode detector. A common use case is, for instance, Apache Tomcat. There, a lot of stuff is already embedded into your application, but when you check it on source code level, you only declare dependency Apache Tomcat, and then with the scope provided. So on source code level, you don't know really what's going on there, but only on runtime, and that's why you need the bytecode detector, or we wrote it that way.
Excellent. That's awesome. That's super helpful and insightful to have those details shared. And again, as Kyle was saying, thank you both so much for taking the time to join us today, give us this insight and amazing work that you all have been doing. Very cool stuff. So props to you all, especially spending that weekend again while Andreas was, kicking back, drinking some beers. Just kidding, Andreas. I know you jumped in too. So thanks for doing that. If there's anywhere, I want to help plug you all a little bit. If there's anywhere people can go to find you on, like on Twitter or GitHub, is there a certain handle they can find you both on to connect with you and maybe collaborate or just reach out for help?
Sure. Let me get I just put it in chat as
Your
well.
website there, if you'd like. I have your
Yeah.
website. Okay.
Yeah, then you can share the website. That's best. There's all information on there, our Twitter handle, our LinkedIn profile, and always, on GitHub as well. On the GitHub Bytecode Detector, you'll find definitely Andreas, me as contributor, and it's easy to find us there. There's also all on our GitHub profiles. There's also our website where there's more information about us personally. So, thanks.
Anything to add, Andreas? It sounded like you might.
No. I just had to just submitted my Twitter handle. If someone can, if someone wants to connect, then please write a direct message, because I must admit I'm really bad at Twitter and not using it so much regularly. But a direct message there is easy to. It's easier to reach me.
For sure. There we go. We got it up on screen, and no problem on that. Totally understand. And as somebody that does use Twitter quite a bit, the DMs there are a little bit difficult for me to keep track of too. So I feel you on that. Excellent. So with that, Andreas and Johannes, I'm going to pull you off the stage, but hang tight real quick, and let's start closing things out, Kyle.
Awesome. Sounds good.
So thanks everybody for joining. We hope you found today's session helpful. Again, big thank you to Andreas and Johannes for joining us and for their work that they've done on this bytecode detection for Log4Shell. We hope you tune into the next one. So be sure to follow along here on Sneak Live. It's twitch.tv/Sneak Live, or if you're over at YouTube, it's just youtube.com/Sneak. I think we got that handle yet. If not, subscribe over there while you're on the channel so that you don't lose track or miss any of the upcoming live sessions that we have going on. We have lots and lots planned for the rest of the year. So be sure to tune in and subscribe to that. Thank you, everybody. Have a good rest of your day, and happy coding.
Bye, everyone. Thanks for coming.